In this set of videos I'm going to be going through setting up this VPC enabled VXLAN EVPN Fabric with Cisco Nexus switches. In this specific video we're going to go through the setup of these VPC domains down at the bottom. So we've got 3 VPC domains, 6 leaves, and then we've got some connected servers down here at the bottom which have already got LACP configured on them connecting to the respective leaves. So there's a few things to set up with the VPC configuration. So we've got ETH1/5, which we're going to use as the peer keep alive between the switches, and then ETH1/3 and 1/4 are going to be configured in a port channel, and they're going to be used as the VPC peer link, which is what's used for the VPC to essentially come up and establish, and it's what the Cisco Fabric Services runs across. So without further ado, we'll get into the configuration. So the first thing we need to do is enable a couple of features. So because we're going to be using the 2 interfaces for the peer link, we need to enable LACP, and then we also need to enable a specific feature for VPC itself. So all of this configuration is just going to be on the leaves. There's nothing to do on the spines at the minute because the spines are still standalone devices. They aren't configured with VPC. So yeah, let's enable the features then. So we want to enable feature LACP, and then we'll do that across all the leaves. And then feature VPC is the second one. So cool, right, we'll start off with the peer keep alive. So what we need to do firstly is configure its own VRF. So we'll enable or we'll configure a VRF called peer keep alive, and the reason for this is that we want to keep this as separate routing wise as possible, so that any underlay routing changes or anything like interfaces going down, recalculations with OSPF and stuff like that cannot impact the routing between the 2 VPC peers, because what can happen if the VPC keep alives or the peer links start to have issues, we can end up with switches becoming split brain, and we really don't want that. So we'll keep it in its own VRF to keep it really separate. So the interface we're going to use is ETH1/5, so we will configure, not 15, we'll configure that. We'll say that it's not a switch port, we'll no shut it. We'll say that it's a member of the peer keep alive VRF, and then we'll give it an IP address. So we'll use 172.16.0.0/31. Let's just grab that configuration, and we'll just, because it's pretty much the same on all the leaves apart from the different IP address. So that is .1. .2. .3. .4. And last but not least, not 5. Thank God for /31s, meaning we don't have to waste a load of IPs with broadcast and network addresses. So let's now configure the VPC domains themselves. So leaf 1 and 2 are in VPC domain 100, so we'll say VPC domain 100. We'll configure the peer keep alive, and what we have to give this is we have to give it a destination and a source. So we'll set the destination in this case to 172.16.0.1, which is the IP of leaf 2, and we'll set the source to our IP address, which is here. And then we have to give it, because we've used a specific VRF, we have to give it the peer keep alive VRF. There's a couple of other things we want to enable while we're in here. So we want to enable peer switch, which is used for mainly for spanning tree, to make sure that these switches are seen by connected devices as one route, so to speak, so that we don't have to mess around with configuring bridge priority on both of the leaves. It kind of is seen as one bridge route essentially. We'll also enable peer gateway, which is a similar construct, but it's for more of the layer 3 forward inside, where both switches will be actively forward for any VIPs that are used between the switches. It's normally commonly used for stuff like HSRP, so if you had HSRP enabled with VPC enabled switches and you had peer gateway configured, even though one of the switches would be active and one would be standby, both switches could and would actively forward that traffic, so it sort of enables both switches to service traffic at the same time. So we'll enable that, and then we'll also enable IP ARP synchronize to make sure that we synchronize ARP entries between the two switches. So the full configuration for that is this. So we will copy that, and we can apply it on leaf 2 as well, and just swap these around. So we're saying the destination is leaf 1 and the source is our IP address on leaf 2, which is .1. So like that. Leaf 3 and 4 very similar, so VPC domain 200, we'll set the peer, keep alive, destination is 172.16.0.3, source is 172.16.0.2, and we'll make sure that we set the peer keep alive, we'll say peer switch, peer gateway, and IP ARP synchronize. And again, we'll grab that and copy and paste it. Just flip these around, so 2 and 3, just like so. Then lastly, VPC domain 300, peer keep alive destination will be 172.16.0.5, and the source is 172.16.0.4. We'll make sure that we set the VRF peer switch, peer gateway, IP ARP synchronize. Grab that and whack it on leaf 6, and just flip these around. So we'll just check while we're here. So if we do a show VPC brief, we will see a lot of red and, you know, peer link not configured and failed and stuff, but what we're looking at for the minute is this peer keep alive status, and we can see that in a minute that it knows that the peer is alive, quote unquote, which is a good sign. So let's just do this on inc keep alive. Cool, so we can see the peer is alive there, leaf 3, peer is alive, leaf 4, peer is alive, leaf 5, peer is alive, and leaf 6, peer is alive. So that's showing that we've successfully sort of configured the keep alive side of things, and the switches can see each other. So next we'll move on to the peer link. So this is what is more heavily utilized in a VPC environment, in that, you know, normal data traffic can transit over it, and it's also what's used for Cisco Fabric Services or CFS OE, which is Cisco Fabric Services over Ethernet. So int eth1/3 and 4, they're the interfaces we're going to use. We're going to put those in a port channel, so we'll say channel group 1 mode active, and we'll no shut them. Cool, so int PO1 switch port mode trunk. It's always normally a trunk because we've got multiple VLANs going across it. It's a Cisco best practice to set the port type to network for spanning tree, and then we've got to specifically call out that this is the peer link. So that's the, in fact, shall run int PO1. That's essentially the port channel configuration that we want, so we'll copy that. So on leaf 2, 1/3 to 4, we'll say channel group 1 mode active. We'll no shut it, or no shut them, because it's two interfaces. And then the port channel configuration. which we will also no shut. And then it's pretty much the same configuration on all the other leaves, so in ETH1/3 to 4, channel group 1 mode active, no shutdown. And then we'll just add no shut onto that. Let that run through. And on the port channel config, and then last on leaf 6, no shut those, and then the port channel configuration on top. Perfect. So that looks good, that looks good, that's good, yep. Let's wait for this and then do some verification. So if we do a show interface status, we should see that these two are connected in the trunk, and then 5 is our peer-link. We should hopefully see, yep, that port channel 1 is connected, so that's a good sign. If it said not connected or no operational members, then we'd know that we'd potentially had a problem with the configuration. So if we do a show VPC brief now, we see more green, and we see that the peer adjacency is formed OK, which means that the VPC peer link is up, and we can also see here that the peer link is up, and at the minute we've only got one VLAN, so it only shows us one VLAN. If we do this on all the other leaves, we should hopefully see similar things. So that all looks good. Leaf 3, that all looks good. Leaf 4, yep, all good. Leaf 5 looks good, and leaf 6 looks good as well. So from a VPC control perspective, everything looks good. So what we need to do lastly is configure the VPCs down to the servers. So I'll do leaf 1 and 2, and then it's exactly the same configuration for leaf 3 and 4. So we'll just copy and paste that. So what we need to do is we are using ETH1/6 on both switches for the VLAN 10 server, and ETH1/7 on both switches for the VLAN 20 server. So let's ETH1/6, we'll say channel group 2 mode active, because we're using LACP. We'll no shut that. We will, for the minute we don't have those VLANs created, so I'm not going to put them on those VLANs, I'm just going to literally create the port channels. So if we do int PO2 switch port mode access, and then there's a specific command that we have to do to make sure that this is seen as a port channel and not just a normal, a VPC port channel rather than a normal port channel. We have to say VPC, and then we have to give it a number. So it's a good practice to keep the VPC number the same as the port channel number, but you don't have to. It has to match though between the two VPC members. So what we'll say is this is VPC2, and then if we come on to leaf 2, ETH1/6, we'll say channel group 2 mode active. We'll no shut that interface, the physical interface that is. And then in the port channel configuration, we'll switch port access, or switch port mode access, because we don't have the VLAN yet. And we'll say VPC2. We will, just for good measure, no shut that as well. and then let's do 1/7 as well. We'll say channel group 3 mode active, PO3 switch port mode access, and then we'll say this is VPC 3, and we'll no shut that. And then on leaf 2 as well, int eth 1/7, channel group 3 mode active, we'll come into that interface, we'll say switch port mode access, and then we'll say VPC 3, and we will no shut that as well. No shut. Right. So now, if we do a show VPC brief, we'll see at the bottom that we have the VPC peer link status, and then we have VPC status. So this gives us the VPC ID, which we set, which we've obviously matched with the port channel ID, and then you know what the kind of status of it is, and we can see at the minute the status is up, so that's a good sign. That means that the VPC itself is up. So show VPC brief on here as well. We can see that they're up and the consistency is successful. So on the server side, we should also see that the port channel, or it's the LACP bond interface on the server side is up. So what we'll do is we'll come onto one of the servers. We can see there that we've got this bond 0 interface, and let's just, not that we're going to be able to have any connection at the minute, but let's just try and ping something in order to send some traffic to the switch. And then if we have a look on leaf 1 and 2 and do a show MAC address table, and then this should be interface PO2, we'll see that we do have a MAC address there. We should see that on leaf 2 as well. We do. We see it via PO2, and this MAC address B384, if we check, is B384. So this is that server. So we can see that port channel is essentially working. Yes, it's in VLAN 1 because we haven't done any of the VXLAN configuration yet, but essentially it's there. So the exact same configuration is applicable for all the other leaves because we've got the exact same port channels. So I'm not going to go through that because it's quite repetitive, but essentially we have the physical interface which is just configured as a normal port channel, and then show run interface PO2. We can see the specific port channel or the VPC configuration. There's not much in there at the moment because the port isn't fully set up for the VLAN and etc. that's going to be on, but that's where we put all that configuration, and then the VPC2 identifier is what identifies that VPC between the two peers. So that's effectively it for this video. So we've gone through and we've set up the VPCs. That was all we wanted to achieve in this video, and in subsequent videos we're going to start going through the actual VXLAN side of the setup, so setting up the underlay, the overlay, bits of multicast, and then adding the VLANs and making sure we've got connectivity. So thank you very much.